Traeger here. Today we're going to talk about triangle similarity and the difference between that and congruence. So our learning target today is that we'll be able to investigate the fact that when two triangles are similar and their common ratio or their scale factor is 1, that they also are considered congruent. You know you'll be successful when you can tell if two shapes are congruent based on if they're exactly the same or not. Let's jump in and we're going to look a little bit at proofs today. So there's two different types we're going to do. We're going to do 4 problems total, 2 of a flowchart proof and 2 of 2-column proofs. So this one is asking us to prove that the triangles are similar. So let's see what we can do here. We know that our options when proving similarity are one of 3 things. We could do side, angle, side. We could do angle, angle, or we could do side, side, side. So I need to kind of decide my game plan between these ones. It looks like I'm given a couple angles in each of them as well as some sides, but I only have one side in triangle ABC. So I'm thinking that proving angle, angle will be easiest, seeing how I've got a set of each of those. So this angle, angle, this little 2-letter acronym is really kind of my game plan. What I can do is say that the facts I know first are that the measure of angle A is equal to the measure of angle D. Now we know this because it was given to us. So when we do a flowchart proof, we write a fact and then write how we know that fact. So we know measure of angle A is equal to measure of angle D because they gave us that with the markings. I also know that the measure of angle B is equal to the measure of angle E. And again, I know this because it was given. So you'll notice the way this is set up is we write a fact and circle it and write our reasoning on the outside. And then the flowchart part of it is that these 2 facts together are going to lead me to the similarity statement, which is triangle ABC is similar to triangle. Now let's match up angles. A matches with D. B with the double mark matches with E. And C matches with F. So I've got this as my conclusion, and again I want to write a reason for that conclusion, and it is because of angle, angle similarity. There's our first flowchart proof. Let's do another. On this one, I notice I have a right angle marked in each, as well as some sides. So because I only have that one angle, that's leading me to think that I'm going to write a statement about side, angle, side. And let's see if that'll work. I've got this side that's 16. That matches with the long side here, the long leg 12, so 16 over 12, which has to equal, seeing how they are similar, the other proportion, 12 over 9. Now, let's check that this is true. 16 over 12 equals 12 over 9. It's good to check with ourselves, so 16 over 12 is 1.3 repeating, and 12 over 9 is also 1.3 repeating. So here's my setup, side, angle, side. Let's do our sides first, but instead of writing it as the fractions with the numbers, I'm going to write this with the letters from the vertices on the triangle. So 16 was IH, and 12 was JL. And that was equal to 12, which was HG, over LK. So here is one fact, and I know this because of proportionate sides. Or I could say proportions. The other thing that I know is that these 2 angles are both right angles, therefore they are congruent. All right angles are congruent to themselves. So the measure of angle H equals the measure of angle L. There's another fact I know, and this was given to me by the markings. With these 2 things together, I know that the 2 triangles are similar, so I can write triangle, I'm going to say IHG is similar to triangle. Now let's be careful, I went down the long leg toward the right angle, so down the long leg toward the right angle will give me JLK. This fact I know based on side, angle, side similarity. Let's try another, this time with a 2-column proof. It looks a little bit different. Our setup is still going to be the same, our mindset will be the same, and what I mean by that is let's think about how I'd prove this. I'm still going to think about angle, side, angles, or I'm sorry, side, angle, side, 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 or angle, angle, and I notice I'm given all sides. So I'm thinking the way I'm going to prove this is with matching those sides up. So the littlest one is 4 here, which goes to the little one 8, so 4 over 8. Actually, I'm going to write it over here. So 4 goes with 8. I also know that 5 goes with 9. And lastly, that 7 goes with 14. The scale factor is times 2 for the 4 and the 8, as well as for the 7 and the 14. But does it work for the 5 and the 9? It actually is not times 2 for the 5 and the 9. This one was times 2, this one was times 2, and this one was not. So on this one, I actually can't do a 2-column proof. So I've proved to myself that they're not similar. So these two triangles are not similar, and there is nothing to prove here because you prove things that are true, and this is not true. Let's do another one. This one won't work out that way. It'll actually play out correctly. So let's see. I was given an angle in each of them. I also have this angle M that's in each triangle, the little one and the big one. So I'm thinking I'm going to do angle similarity on this again, but this time with a 2-column proof. So the way this works is we, on the left column, we write a statement, and on the right column, we write a reason. This is also called a T-chart proof as well. So my statement that I want to say is basically 2 statements, one for one angle, one for the other. So the first angles I'm going to work with are V and this angle here. So this is angle V. I'm going to be really careful here. I'm going to say the measure of angle V is equal to the measure of angle. Now, I can't say angle S because angle S could be this one with the marking or actually this one where my pen is. So to really make sure that we notice that this is this angle, I'm going to say angle NSM. And my reasoning is that this was given to us, it was marked as such. My next one is that angle M is congruent to itself. So the measure of angle M is equal to the measure of angle M. This is kind of a weird thing to write because everything is equal to itself. It's actually a mathematical property. It's called the reflexive property. Once I've got these 2 statements, I can kind of make my conclusion, which is that triangle, let's do NMS, is similar to triangle TMV. And this is because of angle similarity of triangles. So the last thing I want to talk about here is similarity versus congruency. We've been talking similarity up until this point, and let's look at these 2 triangles, and I have 2 questions for us. The first is that are the triangles similar? So let's just convince ourselves. We don't have to write a big proof here, but let's convince ourselves. It looks like we've got a side angle and a side, so I notice the angles are the same, and it looks like 17 matches with 17 and 23 with 23. This definitely is proportionate because I would have done 17 over 17 is 23 over 23, and these are each 1. So yes, definitely by side angle, side similarity. The next question is, what is the scale factor? So usually I can see, oh, it got multiplied by 2 or it got multiplied by 3 or whatever, but the scale factor on this one, it didn't change. The multiplying number that doesn't change is 1. So if my scale factor is 1, aren't these really the same exact triangle? One of them might have got rotated a little bit or translated over, but they're the same triangle. So similarity versus congruency is a topic we're going to learn about next. Congruency has 2 qualities. First off, that the 2 figures are similar. First and foremost, they need to be similar. Secondly, their side lengths have a common ratio of 1. Now this is a really particular way to look at congruency, but really congruency means equal or the same. They are the same exact shape. Now moving forward, we've got our similarity statements. We've learned about angle, side, and side. There are congruency statements for triangles as well, and there's some more of them. These will be on the list as well as some more, and you'll notice that that's going to be kind of something we talk about in the next few videos. I'll see you next time, guys. Bye.